Welcome to the lecture series on digital electronics. So in today's lecture series, we are going to look into the sum of products in Boolean algebra. What does it mean by sum of products? In the last session, we have discussed about the Boolean expressions. This Boolean expression has AND gates and OR gates along with NOT gates, the basic three gates. So see, in between you have the sum as well as the products. So in a digital electronic circuit, the output is a function of digital inputs. The relation between input and output can be represented using logic table or Boolean expressions. This Boolean expressions can be in two forms. One is sum of products and the second one is product of sum. This is sum of product. In sum of product form of expression, the logical OR operations on different product terms. So this is the product term. This is the product terms, right? So sum of product terms. Sum of product terms. This is sum of product form. This sum of product form can be expressed in canonical form or non-canonical form. So what does mean a non-canonical form? So see, if you consider this expression, here this expression is a function of three variables A, B and C. If you consider here, we have three terms. We have three terms, right? This term 1 has only the function A. It do not contain the other two functions B and C. In such a way, if all the terms do not contain all the variables, then we call it as non-canonical form. So in this form, each product term between may or may not contain all the variables of the function. So obviously canonical form is an expression where every term in between the sum, so in the product terms, the products will be the product of all the functions. So here the function is A and B. So see here sum of product, this is SOP form, and in these two terms, right, which is separated by the sum, the two terms contain both the functions. This is canonical form of SOP or POS. And this terms in SOP, we are learning about sum of products. In sum of products, this term is known as min terms. So min terms should contain all the functional variable in a canonical form. So if all the functional variable is not available in all the min terms, then it is known as a non-canonical form. And this is an example. So we have given three inputs and these could be the possible combinations of min terms available. So if you are giving three inputs, then 2 power 3 combinations of min terms will be there. If so, in general, if there are n terms, n inputs, then 2 power n combinations of min terms will be there. Now, the canonical sum of products. So let us find, this is take it as a problem, and we can find the canonical sum of products for this. So given three inputs, and so obviously we'll be having 8 combinations, and the outputs are also being given for different input conditions. So how to form a canonical sum of products? So if you see here, this is known as min terms, right? These terms, if we have three inputs, then we'll be having 2 power 3 min terms. So these are the min terms. So this is min term 0, min term 1, min term 2, min term 3, 4, 5, 6 and 7. So if you see this output, how many min terms are high? We'll be writing all the min terms which are having high output. So M1 is having M2, M3 and M5. So see, the canonical SOP form is function of M1, M2, M3 and M5. So we'll be writing it as, because it is sum of products. So we'll be writing it as M1, M2, M3 and M5. Sorry. So when you consider this F, So the related to M1, the minterm is this one. Related to M1, the minterm is this one, x dash y dash z. X dash is x inverted, y inverted, and z is 1 here, so z as such we have written. Similarly, M2, x, y, z dash. Similarly, M3, x dash, y, z, and M5, x, y, z. So these are the four minterms available and which is separated by sum. So find the non-canonicals. Now we have found the canonical sum of products. If we want to find the non-canonical sum of products, we have to simplify it. If we simplify it, you see here after simplification, I've used certain Boolean laws. So after simplification, if you see here, see this term, the second min term, do not contain the variable z. So if all the min terms contain all the functional variables, then only it is known as canonical form. So here this term is missing z, and so this is a non-canonical form of sum of products. That is the non-canonical form, and even now we can find the minimal sum of products. So in order to find the minimal sum of products, we'll be using K-maps, right? In future discussions, we can discuss in detail about K-map. And now this is in canonical form, the circuit. This is the expression in non-canonical form, and this is the expression in minimal form. After simplification, output of the K-map. You see here the gates are drastically reduced, which obviously reduces the power dissipation, the cost, and everything. Okay, so this is the advantage of using minimizing the digital circuit. This is for your assessment. What is meant by a min-term? Mention the difference between canonical and non-canonical SOP. So thank you.